So I'm still waiting on parts. Everything is such a delay these days. It's taking forever. So I've decided to go ahead and work on the wiring. I haven't got the rest of the fuse box mount and cover, so I decided I'm just going to do away with this. This fuse box, it's cheap to use this. You can use this. It's pretty simple. However, you know, I don't have all the pieces to it, so it is what it is. It's no good if I can't cover it. The problem is I'm missing the part that would go over it to let the actual lid snap down. So, you know, I'm not going to do it that way. So what we're going to do is use an aftermarket fuse box. I ordered this off the internet. So this clump of wires here, which I've already thinned down, is all it takes to run this engine, actually, to, you know, the outputs. So we're going to take this bolt loose, pull this connector out, and start marking each one of these, because my goal is to have the right side injectors and coil packs on one fuse, the left side injectors and coil packs on a fuse, the mass airflow sensor and heated O2s on another fuse, and then the PCM and the diagnostic link and check engine light on another fuse. And there was something else I was gonna, oh, fuel pump. I'll have a fuel pump fuse. Sure is a lot less intimidating now, isn't it? Pulled out all the wires that go back to the PCM. What I've done is I've taken each one and I've traced it back through the harness to the connector, found the pin location, and then matched it, the pin location on here, to what this is. Like right now I'm working on pin 9, which is blue pin 9. That's green pin 9, sorry. Green pin 9 is dark green with a white tracer, fuel pump relay control primary. So then I'm cutting it out of the block that went in the fuel harness, and I match it up, make sure that the color's the same, and then I mark on this little tag what exactly it is. Green connector, pin number 9, so on and so forth. Cut that off, it's the last one, so I don't need that anymore. I'm de-pinning the ECM connectors. So you take each one of them, and in order to access the pins, you have to remove this lock. So this lock goes over top of these, and there's just a little recess right here. And I just take and push in on it just so slightly. I'll show you on this one that's on there. Right in here with a knife, real gently, and then I'll pull just slightly on it. And I'll come to the other side, push on it lightly, and pull, and then the cover comes off. I'll stick this one back on so I'm done with it. Now, in order to access the pins, there's a little lock right in here. So I need to take this next one out. Because I've cut the wire on this side, de-pinning this is easy, because all I have to do is push up. You'll notice the one moving, it will push past the lock, and you just pull it out. Get the tape off your arm, and then when you're done, you've got all the pins out that you want to remove. Just take the pin lock, put it back in. I have a couple more to go yet. Alright, so this is how many pins I took out that we're not using. And I just taped them together. I'm going to throw them in a box with the other parts of the wiring harness, so if we ever decide to add 4L60E or air conditioning or whatever, all the pins are still here. We can put them back in the factory locations, and we'll just put it with that stuff, and we'll put all that together. Alright, so I've mounted the PCM to the inner fender well, and I had 3 bolts that laid flat off of this mount. I got this mount off of Amazon. It was just a kind of a, I don't know what it's supposed to fit, but I saw it was flat and it would work. Only problem was it came up here so far that, you know, the inner fender kind of rolls up. So I took a piece of metal conduit and I cut it at an angle here, straight here, and then I welded a washer to either side so it's good, it's flat. I just ran a long bolt through it, so that should hold it. So now that I've thinned out the harness, I think I'm ready to make a few changes. I'm going to move this plug up into this area just to clean up this, because it's going to come up here anyways. So I'm going to do a little bit of cleaning, and hopefully we're going to be done with this part of the wiring, at least to the PCM. Alright, so some guys were in the live stream while I was doing this wiring, and for those guys that were in there, yeah, I took it back apart. And I added the fuel line, the 12 volt from the relay for the fuel pump, the trailer brake wiring, and a charge line, because those are all going to the back. So I added that, and I pulled out the vehicle speed sensor. I don't know if we're going to need this or not, but I'm going to go ahead and solder that back in, and I'm going to run it in with this pair down the frame, so that if we run into a tuning problem with it stalling, come to a stop, or acting weird, then we'll have it. And I picked up this from Summit. This is basically an interrupter. It puts your cable into here, and then there's an adapter go from here into the transmission. That's laying right there with another shaft to drive it, and it creates a pulse. This pulse is not the same, I believe, as what we need, but it is able to be tuned in the computer. Now, from the factory, or from whoever supplies this, they've added these two solder joints. You can almost feel the wire coming through that heat shrink. So we're not going to use their twisted pair. It's a little inconsistent, to say the least. So we're going to pull it back out of that harness from the original truck and add it in there. Alright, I got this all in. I used one of the retainers from the donor truck that held the harness originally. I only had one of them, so I used a zip tie here and here. I just drilled a hole through the inner fender, ran a zip tie up through a washer, then the inner fender around this, back down through that inner fender and washer, and zip tied it tight. They work pretty well like that. And it's got everything laying okay. It'll be alright. This is the line that has the vehicle speed sensor, the fuel pump power feed, and the trailer brake control, trailer brake wire, and the charge line. Now I put them in this harness and brought them over to here, so they'll be near the fuse box, so we can add them if we want. This spurs off here and hits a TAC module, and then the TAC module has to come in through here still, and then I have these wires right here that need to go in. The brown one is what controls the ground side of my check engine light. The green one is the serial data for communicating with the computer. The blue one is needs power with brake supplied. That actually goes to the TAC module. And then this pink one here is power to the diagnostic link, and that's also going to feed my voltmeter inside. So we have that to go, and this is the harness for the pedal that we have to put inside. So I have to create a hole for this as well. I'm wondering if I can just run the two through the same hole, possibly, and kind of clean this up a little bit instead of having two new holes. I could depin this and run it through a much smaller one, which I might do, but that has to plug in the TAC module there and go inside yet, so I'll work on that next. There's just enough wire to solder that in, so we can put it back in the connector now. So this is where the kick down comes out for the 400. You can see it's a pretty good sized grommet. So I'm going to take the pedal wiring loose from this connector, and I'm going to open this up here and shove these wires through with the kick down on that same one, just so I don't have to put another hole in the firewall. I got that wire through and back in here to the connector for the TAC module, so that's all handled. So I'm working on getting this bundle in here. This is 12 volts to the diagnostic link. This is our power from the stoplight switch, and we have serial data and check engine light. And then also in here are the cruise control wires, which we may be adding. So there's a dimple, was a dimple, down below this bulkhead connector in the truck, and a spot in the insulation that was already popped out. Well, it's made to be popped out. I took it out. So we're gonna put a grommet in there and then bring our wires in right there. All right, so that'll protect the loom that's coming in. It's not a very large amount of wires coming in there, but that's the grommet I had, so we'll use a loom that size. That way it will fit, because I don't like just bringing loom through a jagged edge of metal. This is round 3 on fuse boxes. I was going to use the original. I ordered one. It didn't work, so it was number 2. This is number 3. I found this one, and the reason I didn't use the other one was because it only had 6 fuses. This one has slots for 6 regular ATC fuses like this, which is okay, but it also has these 4 slots for your higher amperage fuses like this style. So what's attractive about that to me is it's going to allow me to run the 2 lines, the constant hots that go into the cab that used to be on fusible links. I'm going to be able to run them into here and do away with fusible links, so it's much easier to change a fuse out. So I'll use 2, and I'll have the other 2 for spares, so there'll always be 2 there to replace them with if need be. It comes with these 2 large relay slots, which these are designed for 40 amp relays. I don't need 2 40 amp relays. What I would like to have is 1 relay turn on these fuses. So when the key's on, this relay powers up these. So they send in the kit 2 of these 40 amp relays. Yeah, there it is. And for those 40 amp relays, check out the terminals they send to hook it up to. So you're able to put, a 10 or an 8 gauge wire on that if you wanted. And then it comes with all the other stuff, fittings. I'm not sure these are going to work for the other relays because they don't have a locking tab to hold them in the fuse box. See how these have a spot for a locking tab, and this doesn't either. I don't know how well they're going to lock in place. We'll have to see. One attractive thing about it to me was the fact that these relays, now it only came with 2 relays and then 6 ATC fuses, but you can run 3 more of your regular amperage relays, and then you can run 2 of these small mini relays, which these didn't come with it, but I have them. So we'll be able to run this style of fuse over here to feed the cab, and like I said, I'll put 2 in here for spares, so they're always there. This post feeds this side, so they're constant hot right there, and then it feeds this post. So if you have anything else, like, a trailer brake charge line, wherever it got to, there it is. There it is right there. Charge line to the back or what have you, we have another post to put it on. Now, I would probably come off of here one of these fuses, makes more sense, or a circuit breaker. But regardless, it gives us a lot of room for changes and things we can adapt. So we're going to give this one a shot. It comes with this box it mounts to. Has an opening. There's nothing here to close that opening, which is kind of crappy. I mean, there's no grommet or anything to slide in here. What I liked about it is I'm going to be able to mount it like this and then set that terminal on it like that to feed it right off the battery. So we're going to start with this and get our layout going. It'll be nice to have everything in this fuse box and do away with the fusible links. Wasn't terribly expensive, 20-ish, 30, right under 30 bucks shipped. I think it was like 25, 27, somewhere in there. So not too bad. So let's get started. I got to make a bracket to set it on first, because I don't want to start until I have it in its location, which I believe is going to be right here like this. And I'm probably going to bring those wires, if they're long enough, they'll bring them in the end. If not, we're going to bring them in the bottom. Alright, so this is what I'm thinking. And I built this little cardboard template. And back here, you can see it's real close up here. And then down here, we're off, setting off the fender because of the curve of the fender. So I just took cardboard and made the template, how it curves there.
Hang on, put it back, you're moving it.
Curves that way, and then it comes down here. It's going to go down here to the inner fender well. I've got it on this little push pin that's holding the splash guard in. That's what's holding it where it's going to go. We'll bring our wires in the bottom of this. The problem is the material that I have is not quite, it's just ever so slightly narrower than these tabs. So, to see if I can live with that. What?
It'll be fine.
Alright, so I don't have a brake, and I could go somewhere and have them make this. I don't, the only metal I have is 1/8 inch, so it's just a little bit narrower. So I think what I'm going to do is clean up the flap disc, lay my template on there, and mark where my bends are, and just cut it, plasma cut it, and weld it back together, because I'll never be able to bend this and a sharp enough angle to make me happy. And this is really too thick a material for what I'm doing, but it's what I got. See the bow on it?
Mm-hmm.
Must have been when they run it through the metal shear or something. You can see there's a little line like right here.
Mm-hmm.
I just started to bend it. Which is going to cause me troubles, you see. I'll have to tack it, because I'm going to set it like this. I'll have to tack that and then squeeze this down. We have a 30-second now. I can do that. I know this detail is really hard to see, but I'm trying to make it to where we have one and the other sticking out. So it gives me a place to lay the weld down through here. See what we can do. Alright, so I was able to lay it down in here. The idea is it just hump up just a little bit so I could flap disc it. I don't want it to look like it's been welded. Okay, so I got a couple small imperfections in here, but I think we're going to live with that. There's a little one here, there's a little one right there. I'm just going to call it good. More than likely when I spray paint that, it'll clean it up anyway. So now we'll go ahead and do the back side. Alright, so here's my bracket for the fuse box, and what I'm going to do is bring in these wires from the engine harness in the bottom. So what we're going to do is I've marked it out. We're going to plasma cut this out so no, the wires won't rub anywhere. And once that's out, I think I'm going to add a brace in the corners just so it doesn't break. I don't know if it's necessary or not. I'm just going to do it anyways. But next we're going to plasma cut this out real quick. It's going to be difficult. I'm going to use a straight edge, but I won't be able to clean that up real well because it's going to be, you know, inside. But I'll do my best. Well, I added the little corner braces in here and then flap disc it, trying to clean them up, make them neat and clean. Got my center hole cut out, so it's all cleaned up now. I'm going to prime it and paint it so we can get it installed. Alright, the paint's all dry. I had forgotten to show I made these tabs here. There's one here and one back here, and those are what bolt to the roll of the fender. So I made them conform to the fender itself, and then it bolts here and here to that inner fender as well. So the paint's all dry. We're ready to put it in. We're going to go over this and make it a little clearer. When we were cutting this loose, we knew that the ignition side was pink. All the pink wires were 12 volts when the ignition is turned on. So we just took them, cut them loose, and you could use the pin out. For me, I didn't really care. I was more it was just simple for me to just ohm them out. I would take each wire where I thought it went, unplug the connector, put my ohm meter, one lead here, one on the other end of the connector. When it toned out, it told me that was the one. So I just went through that and isolated all of them. Now what we're going to do is, there's 3 wires in this one. I've soldered everything and put deox over it on top of the solder, and then put heat shrink over top of that, so we shouldn't have any troubles. Now this fuse right here is going to be a heated O2 for driver side and passenger side, and the mass airflow sensor. That's one fuse. This one right here, which is a little harder to see, it's two oranges. Two orange wires, that is the constant 12-volt supply to the PCM, what we would call keep alive memory. This one, the tag is unfortunately up in here because it was kind of short on wire. This is ignition 12 volt ignition, 12 volts when the ignition is turned on as well. That is one to the diagnostic link, the OBD2 under the dash, one to the TAC module, and two our ignition source to the PCM. And then we have this one here, which is passenger side ignition coil and injectors. So I've separated them. I put all four injectors and the coils on one side on one fuse. And then I did the same thing for the other side. All four injectors and one wire for the ignition coils on one fuse. The theory is in this that if I blow a fuse on one side, maybe it might still run. I mean, theoretically, I probably should have went, nah, there's a difference between theory and reality. If it works or not, we don't know. I don't know, we'll see. And then we have here, there was a ground that was tied in, probably for the relays. That will tie in, but we'll run a separate wire because we're going to run in several relays. This is the wire from the PCM that turns on the relay for the fuel pump. This is the wire that actually goes to the fuel pump and supplies 12 volts. This is our starter wire. We've yet to decide whether I'm going to put that on a relay or not. And these two are for the trailer tow package that we added. So this one would get 12 volts sent to it. This is what's called a charge line. If you have a trailer brake controller and you have trailer brakes on your trailer, usually they have a small battery on there for a breakaway. So in order to keep that charged, you run it through this line. I'm not sure we're hooking this up yet. We may just have it here in case he wants it, may not go through it. This is a trailer brake wire that actually sends the 12 volts to the trailer. This one does not get hooked up in the fuse box because it comes from the trailer brake controller that would be in the truck. So that is how the wiring is going to work. That's how our wiring is set up. The next thing we need to do is get this loomed up as best as we can, what we need, just so it's inside the fuse box, so all of this is protected, and then we can start terminating in here. All right, my fuse box is done. What we did was use the original battery cable to the 03 1500. It had this cable that comes off. I just manipulated it, took a flap disc, trimmed this down to where it would work with this post, drill the hole out a little bit bigger. And then what happens is this post feeds to this post. This is a 100 amp fuse box. So we're feeding constant power off this post to these fuses right here. So number 10 is our starter relay. So we have a 30 amp fuse that feeds a starter relay, which is this one. A 40 amp fuse feeds the main relay. This main relay turns on power with the key. The old wire that used to go to the distributor now turns this relay on in the start and run position. So when it does that, it turns on power to fuses number 5, 4, 3, 2, and 1, and that sends power to our injectors, our coils, our mass airflow sensor, heated O2s, power to the PCM to turn it on, and all that good stuff. So we have all that. Now we needed a way to turn the fuel pump on. The PCM controls the ground side of the relay for the fuel pump. So we're using a fuel pump relay to control the fuel pump. And then we have one more relay here. This one's for our oil pressure switch. Originally this truck had just a light on the dash, and the way it was wired was the light got power sent to the bulb, and then would come down through to the oil pressure switch and off to the choke on the carburetor. Well, the choke had enough resistance to turn the light off once it started running. It's not a complicated system, but it's more than I can explain easily. So this is what it used to be, or it still is. I'm using the original oil pressure switch. The oil pressure switch is open and doesn't close until it gets 5 psi of oil pressure. So at 5 psi of oil pressure, these two contacts close. Now what we need is a way to turn the light off. The light will come on, we need it to go off once we have oil pressure. So what I've done is I've used an extra relay. So we put ignition power to one side of the coil in the relay, and then we're using the oil pressure switch as our ground. So once we get 5 psi of oil pressure, it completes the circuit, energizes the coil, and moves the contact. So what we want is the light to be on, so in the rest position, we have our ground for our light coming up through on the 30. 87A is the wire that goes to the light, which the light is searching for a ground. So when the relay is in the rest position, the light is on. When we get 5 pounds of oil pressure, these contacts close, energize the coil, and bring this off of terminal 87, puts it on 80, takes it off 87A, puts on 87, so our light goes out. So that's what that extra relay is for. And now we should be able to have all our lights come on. There we go. Brake light comes on, check engine light's on, and it should crank on its own. Look at that. She cranks on her own for the first time. Now, I don't have any fuel lines hooked up, a fuel pump, or anything like that. I was just trying to get the wiring finished up. So that's probably going to be it for now. The next step is I got all my fuel components, the fuel tank, the sending unit, the pump, the lines, all that. So the next video will be, or the next part of this will be me dropping the tank and getting all that set up. We're making progress. We got our fan shroud, we got our radiator in. I don't have the right mounts, so I had to order them. So once that comes in, we can move forward on that and just keep going. So I hope you enjoyed.